Hello everyone, in this project we are going to make one robot car. So let's see which component do we need. So we will need Texas Instrument Launchpad, which has the Cortex M4 microcontroller. So we need L290N, which is the DC motor driver. We need actually 12 volt DC power supply. We will use one switch, and also we use the joystick, and we interface this joystick with our microcontroller and able to control these two DC motors that we have. We use actually a long wire to connect to the joystick to have the better maneuver power whenever we are driving our car. So if you take a look to the back side and see what we have on the back. So as you could see here, we have two 12 volt DC motor and two wheels, and also you will need one ball caster for front of your car. So let's have a test drive and see how it works. So let's test our car. So I have my joystick here, so if I push that forward, so the car should go forward. If I push these backward, it should go back. If I push that right, it should be turned right. If I push this joystick to the left, it should be actually turned left. So let's test that. So as you could see, it's go the forward. You could actually come back, again forward, backward, so again forward. So you could actually turn anywhere that you want. So go back, turn around, so turn in the opposite direction, again turn in the opposite direction, go back, forward, and you could actually turn any direction that you want. So let's just turn to this side, again go to the opposite side, back. So as you could see, you could drive to anywhere that you want, and you are able to control your robot car with these joystick that you have. So let's take a look to our circuit diagram that we have. So as you could see, we actually have our Tiva C-Series Launchpad. You have L298N, and we have the joystick here. This is our power supply, and also we have two DC motor here. So let's start with the joystick. So the joystick has 4 pins, so the X, Y, 5 volt, and the ground. So the X connected to PD0, the Y connected to the PD1. So these 5 volt actually connected to the 3.3 volt that we have on our launchpad, and also the ground of the joystick connected to the ground of the microcontroller. Let's take a look to the DC motor. So the positive pins connected to the output 1, negative for output 2 for the first DC motor that we have. For second one, positive to out 3, and the negative to out 4. So take a look to the enable of the L298. Enable A connected to the PF1 and enable B connected to the PF2. So the launchpad ground connected to the L298 ground, and it's also connected to the 12 volt battery that we have, the old ground connected to each other. So take a look to the input 1 connected to the PD2. So input 2 connected to PD3. So input 3 connected to PB0, and also input 4 connected to the PB1, which is port B, pin 1. So L298 has two other pins, 12 volt and 5 volt, and the ground. So definitely ground of the L298 connected to the ground of your battery, and also connected to the ground of your microcontroller. So for these 12 volt pins connected to our power supply, the battery is positive. So it's connected to these 12 pins on your L298 and the 5-volt pin in L298. So connected to the V-bus pins that you have on your Launchpad. So how somehow you use these 5-volt that you have to power these Launchpad that we have here. Just be careful, you could use these 5-volt pin on L298N as an output whenever this power is 12 or less than 12. So whenever you have more than 12, definitely you couldn't use that as an output. So here we actually have less than 12. So for that reason, we could use these 5-volt pin on L298N as a power supply for our Launchpad and connect to the V-bus pin that we have on the Launchpad. So this is circuit diagram. So let's take a look to the codes in Energia and see what we have in our codes. So let's take a look to the code. So as I already explained on the circuit diagram, we connected PF1 to pin enable A on L290N port, PF2 to enable B, output input 1 connected to the PD2, input 2 PD3, input 3 PB0, and input 4 to the PB1. You could actually select any pins that you want, just make sure some of these I/O pins doesn't support analog to digital converter, and also it's actually doesn't support the analog write that we use for PWM. So definitely we use the analog write. So in our code, so you need to be careful whenever you use the pins and select your pins. You should be careful and check the data sheet and make sure whatever you take as a I/O pins, it's able to support what you want to do with that pins. So two variables, integer, pulse width modulation N and B, which is these two will be connected and used to adjust the duty cycle. So here in the setup, you just tells enable A, B, output 1, 2, 3, and 4. So these pins that you already defined will be the output. So then inside your loop, you use the analog read. So you read the PD0 and PD1. So if you check the circuit diagram, PD0 and PD1 is X and Y. So that means somehow you read the value X and Y that you get from this joystick. So I recommend to watch our previous video, which is the interfacing the joystick with Launchpad. So in that video, you saw for my joystick that I use, whenever I'm in the center, I got the number around 1998 in the center for the X-axis, and for the Y-axis, I got the center value is 9075. So again, depend on the joystick that you use, definitely that's number change. So that's what I recommend before you use this joystick. Watch the interfacing the joystick with Launchpad video and follow that instruction, and make sure whenever you change this joystick in X-axis and Y-axis, what is the total number that it's changed. Again, depend on the type of the joystick that you have, because we have too many different type of the joystick, that number is changed. So technically, whenever, because you use the analog to digital converter, definitely that range should be 0 to 4094, because the Launchpad has 12 bits analog to digital converter, and the center number should be the half of the 4094. But in the reality, usually it's less than that number. So that's the reason you need to check that before you use that. For my case, whenever, if you check the previous video, whenever the joystick is centered on the center value, it's give on the x-axis is 1998. Whenever I go to the left on x-axis, it gives me a 0. Whenever I go to the right, it gives me 4093. For y-axis, whenever I'm in center, I got 9075. Whenever I go forward, it gives me a 0. So whenever I go backward, it gives me 4094. So that means in the y-axis, center to the forward, the farthest point that you could push is 9075 to 0, and for backward is 9075 to 4094. For x-axis, so whenever you are in center is 1998 value on your x pins. Whenever you push on the left, you get the 0, and whenever you push the right, so the biggest value you could get is 4093. In other words, in the center, you have 9098 on the X pins. So then whenever you push on the left, the range that it changes is from 1998 to the 0. Whenever you push to the right, it's changed from 1998 to 4093. So as I mentioned, they again depend on which type of the joystick you have, that number will be changed. So that's the reason you need to first test your joystick, watch the interfacing joystick with Launchpad video. It gives you an idea of what I'm talking here. So here you read the X pins and the Y pins of the joystick and use the analog to digital converter and save that value be inside the X and Y. So definitely that number should be between 0 to 4094 in theory for both of them. So here you comes to the y-axis. So you say, as I mentioned, my center value whenever the joystick is in the center, so it is 9075, okay? So for that reason, if you want to know whenever I push from center to the farthest point that I could go in the backward, so the center is 9075. If I go backward in the farthest point, I get 4094. So I actually give a one tolerance. I didn't exactly give 9075. I just give a tolerance which is almost 75. So that's the reason I got these 2050, which is somehow I add these number with 75. So that means whenever y is greater than numbers, so that means I'm in between the center and the farthest point that I could go backward in y-axis. Okay, so what should be happen whenever I'm in that range? Definitely should be go backward. So how you could go backward? So input 1 should be low and input 2 should be high for the motor A. For motor B the same, it should be low, high, that it go to the backward. So definitely for the duty cycle, you couldn't use these range. So you need to have the number between 0 to 255. So that's the reason you use the map function here. So it's actually somehow map 2050, which is centered to the 0. And this point you got on the Y pins whenever you are in the farthest point on the backward. So that number should be 0, should be matched to 255. So that means after these two lines, whenever you are center, the Y is 0. Whenever you are in the farthest point on the backward in Y-axis, it gives you 255. So the same thing for motor B, you have the same range. So the next is Y is smaller than 920. As I mentioned, the center value for my case is 9075. I actually keep the tolerance of 75. That's the reason. So I use a 9000, which is somehow I want to separate or know whenever I move the joystick from center to farthest point to forward. So which is the value change will be changed from this value to 0. So in that case, it should be moved forward. So that means the input 1 should be high, input 2 should be low for motor A. And for motor B should be high and low because it wants to move forward. So that's what you have, these 4 lines. Again, same story. For duty cycle, you need a value in range with 0 to 255. That's the reason you use map function here, which is 92.0 will be matched to the 0 and 0 will be matched to 255. So that means whenever you push the joystick from center to the farthest point in forward, so its value change from 0 to 255. So in the center it is 0, in farthest point in forward should be 255. So if it's not that range, so you just give the duty cycle of the 0 for the both motor that you have. So that means whenever your joystick is on the center, duty cycle is 0 for both motors. So it actually shouldn't be move and shouldn't run. So this is for Y-axis. So do almost the same thing for the X-axis. As I mentioned, the center value whenever the joystick is the center, I got 9098. I give one almost 100 or 98 tolerance, so that I use these range. Whenever X is smaller than 9020, so that means I'm in the center of the joystick, and whenever I push from the center on X-axis to the farthest point on the left, the value will be changed 0 to 9020. So that means whenever I push the joystick to the left, this is how I could know that is in the left based off these range. So then if it's there, you need again use the map. It's actually changed that range, which is from 9000 will be mapped to the 0, 0 will be to 255. So this 0 is when you are in the farthest point on the left on the X-axis. That's why we actually matched it with 255. So you got that value, so then you increase the duty cycle of the motor B with this number that you got here, which is depend on the value that you got from the joystick pin X, and decrease the duty cycle of the A with the same value. So what's happened here? You want to, whenever you push the joystick to the left, you should turn left. So the motor A is whatever you have on the left side of your car. The B is whatever you have on the right side. So if you want to move left, you need to keep the motor that you have on your left small number, then turn the right side motor faster. So if the right side motor actually turned faster than A, this is what happened. So it's actually turned to your left. So that's what you have these two value here. So technically it's just because the p value A is actually 0 whenever it is center. So that means technically all the time you keep these PWMA 0. So in the reality what's happened in the car, whenever you want to turn left, you keep no turn for the left motor and you just turn the right motor, which is the B, so that you are able to turn the left. So here you increase the duty cycle, here you decrease. Definitely you should have one if statement. If this goes to the negative, again it's put at 0. If it goes over 255, again it's back at 255. That's the reason you have to these if statement. Same thing whenever you turn your joystick to the right, center to the farthest point on the right. So as I already mentioned, so whenever you are on the center, my joystick give 9098. Whenever you are on the farthest point on the right, it's give 4093. So I give one tolerance, so I add 100 to that range. I say, okay, whenever X is greater than 2120, which is somehow is a range that you know you push the joystick to the right side. So in this, so then you use the map, which is whenever it is in 2120, should be give you a 0 to the IT cycle. Whenever you are in 4094, which is happen whenever you are in the farthest point on your right, it should give you a 254.5. So in other words, whenever you change that from center to the farthest in the right, the value change from 0 to 255, and it should be turned to the right. So that's the reason you see this time you actually turn the motor A, which is on your left, faster than the B. So see the motor A add with this value, but the motor B duty cycle subtract with this. So that means motor A, which you have on the left side, it's turned faster than B. So that means it's actually turned the car to the right side. Similar with the previous one, you just, because this is shouldn't be exceed 255, it shouldn't be go the negative. You just have these two if statement, which is keep these pulse width modulation of the B on the 0 whenever it is negative, and this one keep that's 255 whenever it's over that. So here just two if statement for prevent the buzzing. So whenever you don't have enough duty cycle to turn the motor, you want to avoid that case. So that reason you have these two if statement. And finally, you just write these pulse width modulation that you got from the any situation that you have, and write that inside the enable A and enable B. So this is how code works, that you upload them to the microcontroller and test our robot car. So let's test our car. So I have my joystick here. So if I push that forward, so the car should be go forward. If I push these backward, it should go back. If I push that right, it should be turned right. If I push this joystick to the left, it should be actually turn left. So let's test that. So as you could see, it's go the forward. You could actually come back, again forward, backward, so again forward. So you could actually turn anywhere that you want. So go back, turn around, so turn in the opposite direction, again turn on the opposite direction, go back, forward, and you could actually turn any direction that you want. So let's just turn to this side, again go to the opposite side, back. So as you could see, you could drive to anywhere that you want, and you are able to control your robot car with these joystick that you have.